The secret of the lost submarine, Titan, lessons in pressure engineering. In the summer of 2023, the world paused in shock as news broke of the disappearance of the tourist submersible Titan during its descent to the wreck of the legendary Titanic in the North Atlantic Ocean. What was meant to be a unique adventure-blending exploration and modern technology turned into a tragic event that raised profound scientific and engineering questions. The loss of Titan was not merely a technical accident. It exposed the immense challenges of deep-sea engineering and highlighted the limits of innovation when it is not supported by rigorous safety standards. A journey into a world without light. The remains of the Titanic lie about 3,800 meters beneath the ocean's surface. At this depth, complete darkness prevails, temperatures approach freezing, and pressure rises to levels far beyond what most industrial materials can withstand. Descending to such depths is like placing an object under the weight of thousands of tons. For this reason, deep-sea submersibles are among the most complex machines ever built. They must be strong enough to resist crushing pressure while remaining precise and reliable enough to protect human life. The Titan submersible. Innovation or engineering gamble? Titan was developed by a private company aiming to reduce costs and make deep-sea tourism more accessible. Its design relied on a combination of titanium and carbon fiber, rather than a fully metallic pressure hull. In theory, carbon fiber is lightweight and extremely strong, widely used in aerospace and high-performance engineering. However, under extreme and repeated pressure cycles, carbon fiber behaves differently than metals. It can develop internal microcracks that are difficult to detect and may worsen over time. Several experts had previously expressed concerns about this choice, warning that carbon fiber does not provide clear warning signs before catastrophic failure, unlike metals, which tend to deform gradually. The moment of silence and the beginning of disaster. Less than 2 hours into the dive, communication between Titan and its support vessel was lost. An international search and rescue operation was launched, involving ships, aircraft, and deep-sea robotic vehicles. Days later, debris from the submersible was discovered near the Titanic wreck site. Investigators confirmed that Titan had suffered a sudden structural collapse due to overwhelming pressure, an event known as an implosion, which occurs in fractions of a second and leaves no chance for survival. What is an implosion? Unlike an explosion, which pushes outward, an implosion happens when external pressure overwhelms a structure, causing it to collapse inward violently. At depths of nearly 4,000 meters, pressure exceeds 380 times that at sea level. Even a tiny structural weakness can trigger total failure. In Titan's case, accumulated damage within the carbon fiber hull is believed to have reached a critical point. Safety standards under scrutiny. The tragedy sparked global debate about engineering ethics and safety regulations. Reports revealed that the submersible had not undergone certain internationally recognized certification processes, relying instead on internal testing. This raised an uncomfortable but essential question. Is it acceptable to risk human lives in the name of innovation or cost reduction? Many engineers argue that deep-sea exploration must remain a highly regulated scientific endeavor, not an experimental commercial venture. Lessons from the depths. The Titan disaster offers several powerful reminders. Nature does not tolerate small mistakes. Advanced materials are not always the safest choice in extreme environments. Safety standards are essential, not optional. Expert warnings should never be ignored. True innovation balances ambition with responsibility. Conclusion. The mystery of the Titan submersible is more than a tragic story. It is a sobering lesson about humanity's limits in the face of nature's power. In the deep ocean, there is no room for shortcuts or untested risks. Perhaps the most important message left behind by this tragedy is that scientific progress should not be measured by how fast we reach the unknown, but by how safely we return from it.